Okay, so remember the code that we created here in our balances and in our system palettes. Now the types, you have these types as generics. The problem with this configuration is that, okay, we have three types here and we are passing all these three, but imagine that the palette had others, different types. So imagine a list of 5, 6, 7 different types here. It will be huge, and it's really hard to read codes when you have different generics added to the typing system here. So we want to find a way to pass only one type, and this type encapsulates other types. So for this, we are going to introduce the use of traits. So in Rust, what is a trait? The trait has basically two things. The first thing is that you can add functions, as we learned before. So for example, if you have this trait called getName, when you implement this trait for a specific struct, you add the implementation. So basically, the trait is the interface that something will have. The same way we use here, we added traits. For example, 0 or 1, these are traits that we are adding. So block number will implement these different traits when we explicitly say that we have this trait. So we're gonna create our own trait right now, and this trait will be our configuration. So instead of passing all this, imagine that we had like hundreds of configuration, or this list would have been nice. So the idea is that we create a trait called config. So let's copy this code here and add it here to our system palette. So instead of having these types directly into the generics, we created a trait called config inside our module, and then we add these. What are the restrictions of this different types? So in this case, account ID is ord and clone. The block number is 0, 1, checked add a sign. So actually checked sub we don't need. I'm gonna keep them. We don't also need, I think we don't need this as well. Yeah, this is how it is here. And the same goes for, we don't need clone as well, as long as I know. 0, 1, and copy. And ord, I think it's not necessary as well. Okay, so so these are the types that we defined before. Now, what we are going to do is that instead of using, instead of passing the list of types here, we will simply say that our palette will depend on something that implements this config trait. So t comma config, which means t column config, which means this palette will receive a type t, doesn't matter what type is, but this type must implement this trait here. Okay, and now we can use the internal types in the trait within our palette. So in this case, we use this double column here, and then everything is much easier. So the same goes for the implementation. So instead of passing all this stuff, we pass t config and then palette of type t. So you see, the same goes. We don't need to this where anymore because this restriction is already defined here. So we already know all these types in here. So we don't need them anymore as a restriction. Okay. And then, of course, now we have t. We can use them block number. We can use block number here. And we can use block number over here. So, okay, account ID goes the same. and the same goes here, and the same goes for nonce. Nonce. Everything, everywhere I use the type, I need to refer to the trait that I just created, which is the config. Okay, and now instead of passing these parameters here, I need to create my own config. So in our tests, I need to implement this config for my test config, something like that. So for example, I have my, let's say I have a struct here, struct test config, and then I will implement config for my test config, and then set up I set up a super palette. I think it's super config like this. Yes, super config. And then here I just need to pass the type here, test config, and here test config as well. And also test config over here. And if I did not do anything wrong, let me run it. And yeah, of course, I also need to change I need to change now the runtime, because now it doesn't accept this, but I need to implement the config for the runtime as well. So I'm going to implement system config for runtime, and then I just refer to the types described over here, and then I don't need to do anything here. I just need to pass runtime because it already implements the type. Okay, so let's run it. Still there is one undeclared types, nonce. There's something missing. Where? System nonce. I think, yeah, I think yeah, I need to import the nonce. What is happening here? There's something missing in my system, because I have the block number. For some reason, I forgot to put the T here. Okay, this was missing, and then everything is working. So again, now I have a configuration here. You see, is much better because we can add many more types, and we don't need to change anything in our code anymore. So it's easier to do this, and we are going to repeat these steps in the balances palette in the next lesson. So it's going to be very clear how to make this transformation. Instead of using a multiple list of generics types in the palette, we use a single config one, a single trait, and then we implement this config in our usage here in the runtime, or also in the testing environments.